Welcome to solverfy.
Okay, I've been asked to draw the structure of 1s, 3r, 3 tert butyl, cyclohex, and 1 amine. Okay, well, we know that we have an amine and that it is a primary amine given the numbering scheme here. So we know that we have a nitrogen with 2 hydrogens, and that this nitrogen with 2 hydrogens is attached to a carbon, and this carbon will be carbon 1. Let's do it at an angle instead, actually. Okay, so whatever is here is going to be carbon 1. Well, what is the main component of our chain or molecule? We go back one further. We've taken care of 1 amine, and now we look to cyclohexan. That is a 6-membered ring with no double or triple bonds. The "and" tells us that it is purely an alkane, not an alkene or an alkyne. Okay, so now we know that this is coming off of a 6-membered ring. Let's draw that 6-membered ring. And we know that this is carbon 1 on that 6-membered ring. Okay, now let us continue. What else do we know about the molecule? Well, we know on carbon 3 there is a tert butyl group, right? And so here is pretty much arbitrary. We can say 1, 2, 3 or 1, 2, 3. Let's just put it over here. Why not? Let's call this carbon 3 and put our tert butyl group there. So now we have handled everything to do with the molecule except for the stereochemical designation. So let's handle that. Now, the way I like to do this is to simply guess by putting a wedge to all the substituents. And then I look at the wedge and determine whether this is indeed S. And if it's not, I flip the wedge into a dash. So that's exactly how I'm going to do it here. I'm going to add the implied hydrogen, which must be on a dash if the amine is on a wedge. I'll do the same here. And now I will determine the designation of this stereocenter. Okay, well, in terms of Kohn-Ingold-Prelog rules, CIP, we know that nitrogen is the highest priority group here. Then we've got carbon versus carbon. Those are tied, so we step one further down the ring. Remember that these each have hydrogen, 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 and a carbon attached. That's what makes them tied, despite both being, in addition to both being carbons. And then we look at these carbons further down the ring and say, okay, this one's got hydrogen, hydrogen, and carbon, whereas this one has carbon, carbon, and hydrogen, right? So the 2 carbons will make this higher priority than the carbon with 1 carbon attached. So we've settled that the uppermost carbon between the 2 we're choosing from has the higher priority. This is priority 2, this is 3, and the hydrogen in the back is 4. At this point, we can go from 1 to 2 to 3 and see that we are counterclockwise, and our lowest priority substituent is in the back of our molecule. So counterclockwise, lowest in back, that corresponds to S. Clockwise with lowest in the back corresponds to R, and counterclockwise with lowest not in the back corresponds to R, while clockwise with lowest priority not in the back corresponds to S. Okay, so there's the rules for reading the clockwise, counterclockwise, depending on the position of the lowest priority substituent. Nevertheless, we have determined that the stereocenter at carbon 1 here, being counterclockwise with the lowest priority substituent in the back, is S. And hey, that's what we wanted, 1S. So we guessed correctly. And that's what I mean by guessing. Right? If we had gotten that this is R, we would simply swap the wedge and the hash, which would swap the S to an R because the lowest priority substituent will all of a sudden not be in the back. Okay, let's now figure out the stereochemical designation of carbon 3. We know that hydrogen will be the lowest priority. Then we've got carbon versus carbon versus carbon. Those are tied, but note that this carbon leads to 3 carbons, while these ones lead to carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen, meaning this carbon is the winner. So the highest priority is RT-butyl, and then these two are still tied, but we go one further down the ring, and we see that this carbon is attached to nitrogen, while this one is attached only to carbon and 2 hydrogens. Nitrogen's higher priority than anything this carbon is attached to, so we know that in terms of priority, this carbon is number 2, and this one is 3. And just like last time, we now connect 1 to 2 to 3, and determine that this is clockwise. And similarly, our lowest priority substituent is in the back. If we are clockwise and our lowest priority substituent is in the back, then we are talking about R. So we have an R at carbon 3, which means the structure we drew, or the guess we made, was correct. So now I will just redraw this on its own, just to make it a little cleaner, leaving out the unnecessary implied hydrogens, NH2, and T-butyl.